A very good morning to all of you. This side Mitali Triwal, your public relation officer, and it is my privilege to host the event for the inauguration of Building of Chemistry. And there are some famous statement about the chemistry that chemistry state that the more energy you put in any bond, the harder it is to break. So whether it is a bond between ourselves or between you and your thought process, if we put in the adequate energy into it, then obviously we'll get the best result out of it. So with this thought, I will not take much time and I will request our chief mentor, Director IT Hyderabad, Professor Moti, to please come on the dais. And I request, and we are happy that we are happy to pleased to welcome University Professor and Dr. Kalam University of Hyderabad, Professor Govardhan Mehta is the chief guest of the event. And I request our chairman, Dr. B.R. Mohan Reddy Garu, to please grace the dais. I request team planning, Professor K.V.S. Subramanian, to please come on the dais. Request Professor Tatarayana, head of the Department of Chemistry, to please grace the dais. So thanks for your all warm welcome being present here. Now I request our director to please propose a welcome address.
Good morning, friends. Good to see a lot of students. I think the first inauguration of a building on the campus where we are seeing so many students. Of course, most of the other buildings have happened when you are not on the campus, and that's a happy thing that you are all back on the campus and we have the chemistry building being inaugurated today. So as you know, this is a part of the second phase construction that is going on, and a large number of these individual departmental buildings are coming up one by one. We had the material science that was ready, I think last year, August 18th, if I remember right, it was inaugurated. And then November, we had biotechnology, biomedical, and now we have this, and the other departments are in the close to final stages, I would say. Maybe by October, November, we will have most of these departments getting ready. So, and we are eagerly looking forward to all of you being accommodated in these buildings and see that the research and academics flourishes. And we have been doing exceedingly well, as you all know, in our academics and research. And if you see most of the parameters that people look at in terms of various ratings, various rankings, IT has been prominently placed. And that is something which is thanks to quite a number of very active and passionate faculty members and strong student body that we have, and the staff who have been significantly contributing for the growth of IIT Hyderabad. I look forward to more and more cooperation from all of you to see that we bring out much more innovative programs. As we always say, IITH stands for innovation, and we have a great gentleman sitting here, Dr. B.R. Mohan Reddy Garu, who always supports all the innovative ideas that IITH comes with, and to the extent that he is also contributing in a big way to a school of innovation and entrepreneurship, which is just going to get ready by, I think, next August, sir. By next August, we will have that building ready. And many of you are aware that we have a Department of Entrepreneurship and Management, which is going to be housed in that school. And we are eagerly looking forward to that. And similarly, we have many other innovations happening on the campus. Some of you are possibly aware that we have a school of sustainability and climate change, which is going to come very soon. And about 100 crores have been committed by the Greenco company and Greenco Foundation. And so that is another very important activity that is going to happen. And in addition, with various healthcare, I would say, partners, we have started a number of programs. You are aware of an MTech in ophthalmic engineering, which we started about a week back and 15 days back, August 1st. And LV Prasad team is keen to start an eye care facility come research center at the campus, which caters to the research that is happening in biotech, biomed, and materials engineering, and various other departments in the area of eye care, and also caters to all the villages that are nearby, so that we do to the whatever extent that is possible to help the needy, at the same time ensure that we do excellent research in the area of healthcare. So that's another new thing you would see very soon. We will have a foundation stone for that particular center also going to be laid, and you would see possibly in a year a clinic coming up there, and in addition the departments of various material science, as I mentioned to you, biotech, biomed, which are all working in those areas, getting benefited with that. So there are many ideas that are being worked out. I'm very happy that there is a very strong enthusiasm and energy that IITH stands for. And as we always, I keep telling to everybody, 280 faculty with an average age of 38. I don't think you'll see anywhere in India an institute of this nature. And that's the strength of us, and beaming student capacity of around close to about 4,000 now, which we would like to see in the next 1 year, 2 years, increasing to about 5,000. And with the new hostels that are all getting ready, I'm sure all our dreams will come true. And then we'll be able to have a wonderful campus by the end of this year, with all the departments being ready for occupation, hostels ready for the students to take, and then a lot of activity, both in research and in academics, trying to bring in as much innovation as possible to ensure that IIT Hyderabad becomes a leader in both teaching, research, and technology development in the years to come. With those few words, thank you very much for this opportunity.
Thanks a lot, sir, for always inspiring us. Now, since talk about how big we are going, I thought I take a moment to talk about what the magnanimous facility we have inaugurated today. So this building of chemistry is G+5 structure, having a built area of 10,000 square meter and having a 4 plate, each of them of 2,000 square meter. The building has a wonderful 10 unit facility, which include 3 classrooms, each with a capacity of 120, 42, and 24. It has almost 38 faculty rooms, computer research lab 4 common instrumental lab, organic lab 11, conference room 1, emergency shower 12 number, 11 organic lab, 10 physical chemistry lab, and dry ice room 1. So with this wonderful facility, I'm sure you will do wonderful research. And now I request our source of inspiration, Dr. Divya Mohan Reddy Garu, Chairman BOT IITS, to please proceed over the delivery.
Professor Govardhan Mehta, Professor B.S. Murthy, Professor Subramaniam, Professor Sachinarayana, several of our faculty members, and very dear students. A very good morning to all of you. Since a year, we have been inaugurating buildings after buildings, and certainly it makes one feel very gratified, because all the effort that's gone in several years since we started this campus, we're now seeing the fruits of it in the shape of buildings in the campus, and for all of you to be there in these buildings. A good reflection of that is when we came here at about 10:40 or so, and we're waiting for all of you to come by, and people told us that the students were so excited that they were going around the building and taking pictures of at various locations. That's a good reflection of how interested you are in your department. Equally important today is something which I felt very refreshing and delightful. If you look at around you in the audience, you'll see a large population of our girl students, which to me is is something which I think I look forward to for future. No nation, I keep saying, no society, no family ever prospered without participation of women. And in the recent past, people have been talking about the population of the net addition of population is coming down. As a result, would Indian economy grow as fast as what it has done in the past? But the good news is that there's a fairly large headroom in women participating in our economy. Unlike the West, in India, today, the women participation in our building our economy is no more than 20%. And hopefully, if it reaches what happens in the West at about 40 or 45%, you could just imagine what all of you could do together. Sure, I'm not in any way saying the men are not important. Men are equally important, but I am really delighted that all of you are here. Congratulations for the new department, that's department building that has been inaugurated. Very spacious building. Mitali gave you all the statistics. 10,000 square meters, right? 1 lakh, 1.1 lakhs or so. So it's now for all of you to work in those facilities to produce something which all of us will be proud about. I think what is important is that I keep saying this too fairly often, that research is important. Publications are equally important. But ultimately, I like to see what the outcomes are. How does this research benefit mankind at the end of it? So therefore, please bear with me and listen to me to say that, look, we'll do research all right. We'll make these publications. There'll be a lot of referrals that will go to the publication, but ultimately we need to see some benefits that will accrue back to the mankind or back to the people who are actually funding them, not because they want to become rich. They can fund more to ensure that we will have better society to live. For today's event, we couldn't have found a better chief guest than Professor Govardhan Mehta. I was a student. I was not fortunate enough to listen to his classes, but I was on the same campus when he was teaching at IIT Kanpur. And I'm sure many of you would have realized IIT Kanpur had the best chemistry department in the country in the 70s, 80s, and even now it gets cited as one of the best departments, led by Professor C.N.R. Rao, and of course, with many stalwarts like Professor Govardhan Mehta. We watched him thereafter, how he grew. And so he's an academician par excellence. Students love his teaching. I've had enormous amount of feedback. And where he is in his life, he is a few years ahead of me. I'm not too far behind him, but continues to be there at his research desk every day. That's the commitment every one of you have to learn and get motivated. And thirdly, he's an institution builder. He's provided the leadership for many institutions, including University of Hyderabad as a vice chancellor, IISc Bangalore as the director, and scale those institutions to a higher level. So therefore, I think we couldn't have had better chief guest for our inauguration. It augurs well with our future. Let's join our hands to welcome our chief guest. I'll leave just one thought with you. Our belief in life, people like me who've been in this field of technology, is that technology will continue to accelerate at a pace which is faster than what has happened in the past. It's whether it's computing, communication, sensors, algorithms, and so on and so forth. But what we will see in this decade and a decade more to come is the application of this technology into many areas, and especially for people like you who are interested in chemistry, we'll see enormous amount of progress in chemistry, biotechnology, material sciences, a combination of all three of them. And that's how I think that quadrangle has been built with future in mind. And there's some signs of that's already happening. There is tremendous amount of progress that's being made in protein at this point of time. Genomics, biosynthetics, all of them are being driven by technology behind it. You saw how we got the vaccines coming out. Vaccines took in the past 10 years. Vaccines for COVID-19 came in about 9 to 10 months. What was underlying that was technology. So you people are very fortunate to have not only chemistry as the background, but an ability to work interdepartmental with the best of infrastructure. So what's left is your attitude. If you apply yourself well, you will be the best. God bless you. Thank you.
Thanks a lot, sir, for emphasizing on having an attitude which result into benefit application and result-oriented research, and obviously to with the keeping pace with the future. So now I invite Professor G. Satyanarayana, Head of the Department Chemistry, to introduce our chief guest.
Actually, Mohan Reddy Garu has already introduced.
So good morning, Honorable Chief Guest, ladies and gentlemen. It gives me immense pleasure to take this opportunity to extend a warm welcome to our Chief Guest, Professor Gordon Mehta sir, our Chairman BOG, Dr. B.V.R. Mohan Reddy Garu, Director Professor B.S. Murthy Garu, faculty, staff, and beloved students to the inauguration of the chemistry building. So it is my great privilege to introduce Professor Gordon Mehta sir to this audience. Professor Mehta is a leading researcher both nationally as well as internationally in the area of chemical sciences. He is presently at the University Distinguished Professor and Dr. Kalam Anjireddy Chair Professor at the University of Hyderabad. In the past, he was a faculty at IIT Kanpur and Vice Chancellor of the University of Hyderabad, and also the Director of IISc Bangalore, and also the Srinivas Ramanujan Research Professor of Indian National Science Academy, CSR Bhatnagar Fellow, National Research Professor of Government of India, and Lilly Jubilant Chair Professor at the University of Hyderabad. His research interests have been diverse, but main focus has been on the total synthesis of natural products. He has published around 600 research papers and guided over 100 doctoral and postdoctoral researchers. He has been actively involved with the science policies and also higher education issues, both nationally as well as internationally. So Professor Mehta is a fellow of Royal Society, a foreign member of Russian Academy of Science, fellow of the World of Academy of Sciences, honorary fellow of the Royal Society of Chemistry. He is also a fellow of the 3 science academies in India and was the president of the Indian National Science Academy. International Council for Science, Paris, and Chemical Research Society of India. He has been the recipient of Shanti Swarup Bhatnagar Prize, and he has been conferred a Padma Award by the President of India. So finally, from the bottom of my heart, and on behalf of whole IITH fraternity, I thank Professor Mehta sir for kindly accepting our invitation to grace the occasion. I now request Professor Mehta sir to inspire us with his motivational speech. Thank you very much.
Do I still have the time allocated to me? Because I went by your program, and we academics have a tendency to meander. And as a teacher of long standing, once you start me, I wouldn't know when to stop. And therefore, I have written down something. So I will read through this so I know when to stop. Because when the text runs out, I will have nothing to talk about. Let me first of all offer you a very good morning, and also it's a very unique occasion for me. This is an occasion to savor. Being an academic and a chemist, I am particularly delighted and privileged to be here. Before I convey or share a few thoughts with you, let me say a word of appreciation for IIT Hyderabad. And let me spend a moment going down the memory lane. I recall discussions on to be established 8 new IITs over 15 years back, when the new 8 new IITs were on the horizon and discussions were going on back. At a discussion at that time, a concern was expressed that these new institutes should not be clones of the well-recognized and well-established older IITs, but must endeavor to invent a new identity with a lofty ambition and positioning as prime 21st century institution. You know, it was recognized at that time that IITs are a great brand, perhaps one of the best known Indian brands, but this happened in 20th century. What about 21st century? So it was at that time discussed that we should create a new brand from India in higher education, science and research arena for the 21st century. And this was the idea. Okay. In this context, IIT Hyderabad has evolved through a well-defined trajectory, navigated its advance, and positions itself in the competitive higher education landscape, and therefore deserves all the accolades. I would like to believe that you are on the way to become a leading institutions of higher education and research in the country in the 21st century. So well done, and keep moving. I must also recall the contributions and the leadership provided not only by Dr. Mohan Reddy and Dr. Murthy, but also your predecessors. Because, you know, institution is like a river. We all come, play our role, and recharge. Most of the time, it is recharged well. Sometimes some pollution also gets into the system, but that's the way the evolution takes place. So we should accept that reality. You are very fortunate that your short lifespan so far, you were very fortunate to have association with very enlightened people. My congratulations and good wishes to the chemistry community here as you move to your new impressive abode. We are already in this abode. Good luck. While chemistry has, in this institution, done quite well, this physical movement of premises needs to be accompanied with new ideation and new expression of your creative instincts. Chemistry learning and practice urgently needs rejuvenation globally. I'm not revealing a secret. I think chemistry no longer is the discipline it used to be. It has to evolve in place for 21st century, and I'll share with you why it has to do that. Our science has served well, and without chemistry, we would not have been sitting here today. You know, I'm making a very strong statement that without chemistry, we would not be sitting here today. So I must justify. Why do I say this? Because of the fact that nature's nitrogen fixation capability can only feed 2 billion people. You know, food is grown through nitrogen. It's a necessary part, and you all chemists know. And nitrogen fixation is fundamental to human survival on the planet. The nature's capacity is only for 2 billion people. But today, at the dawn of this millennium in particular, we have 8 billion people and achieved certain level of food sufficiency. 8 billion people. How it has happened? It has happened because of one molecule, ammonia. Because of course you know well that ammonia is transformed into urea, and urea goes into all kinds of fertilizer preparation, and that has enabled us to survive. The 2 billion landmark capacity of nature to fix nitrogen was achieved in 1920 when the world population crossed 2 billion. So how are 8 billion people surviving today? So that I leave it to you. In fact, its importance is best highlighted by the fact that the journal Nature, iconic journal Nature, ran a global survey asking which is the greatest scientific discovery of the millennium. You know, we just were crossing into 21st century, and so Nature conducted this survey. You'll be surprised. The winner was not the predicted one, like discovery of Newtonian gravitation, which was a landmark. It was not Einstein's theory of relativity. It was not Darwinian evolution or Madame Curie's discovery of radioactivity, or even at that time, the hot issue of mapping of the human genome, which is completely transformed. So I've just shared with you some of the highlights of what have happened in last few hundred years. But the Nature survey revealed that the greatest discovery of the millennium was the Haber-Bosch process for ammonia, which is not generally in the public mind, but you can see what difference it made. This chemistry discovery ensured that we are all still around. However, ammonia synthesis is a double-edged sword, and actually this is going to be a theme that I will dwell repeatedly. Why it is a double-edged sword? The manufacture of ammonia, listen carefully to what I say. The manufacture of ammonia accounts for 2% of global energy. 2% of global energy is spent in the manufacture of one single molecule. Therefore, it is a huge, unsustainable energy guzzler. But we cannot live without ammonia. And I will have a few things to say about it. But just telling you, great discoveries are made in science, in chemistry, but they are intrinsically unsustainable. And I would like to illustrate it by last year, there have been two wake-up calls for humanity and our planet. So you will see that, chemistry deals with molecular world. We all deal with atoms and molecules. But I will like to connect you that this molecular world of chemistry has profound influences on planetary scale. And we should now begin to think, what is this connection between molecular level events in which chemists have expertise and the planetary consequences of the work that chemists do and the way the development of our world is taking place. So last year, there have been two wake-up calls for humanity and planet. It has been, and listen carefully, what are these wake-up calls? Every young graduate, every young citizen of our country and of the world should be aware of what these two wake-up calls are. Not many people know because it doesn't concern your daily life, because this is about future. And most of us are quite happy thinking about today, at best tomorrow, day after tomorrow, or something. It has been estimated that in year 2020, 2 years ago, global human-made mass, often called anthropogenic mass, because human activity produces this mass, exceeded all living biomass on the planet. We are making more anthropogenic mass by our activities, manufacturing, living activities, etc., than the nature makes on the planet. This is startling, but it's a fact now established through very, I would say, involved modeling studies done by Israeli scientists reported in Nature a couple of years back. A substantial portion of this human-made mass, although inevitable, because life has to go on, so you need different matters to sustain life and our everyday activities. But this is produced through diverse, at times inefficient, and unsustainable chemical and material processing. Indeed, this critical crossover point was breached very recently. And it might interest you. You know what is the mass of all human beings on the planet? How much 8 billion people on the planet weigh? I will not share with you the number, but they only account for 0.01% of global mass. The entire human population on the planet, 0.01%. That means each one of the human on the planet is creating 100-fold excess of its own weight to live. How long can you sustain it? That's the issue we should think about. Okay. The second alert that appeared only a few months back is that safe operating space of the planetary boundary. Don't worry about, there is a planetary boundary. Many of us don't understand. We think boundary is our domestic house fencing. There is something called planetary boundary. And in the last few years, the concept of planetary boundaries, which transcends the geographical boundaries, which are political in nature. But there is this planet for all one of us. And the finding is that planetary boundary of novel chemical entities has already been exceeded. There is no room for more chemicals. And you know that almost 1 billion chemical entities are known today. So this calls for rethinking the production and release of new chemical entities. This will inevitably have major impact on chemical industry and on material processing in the coming decades. Clearly, a continuum of innovations in chemical processing and manufacturing in quest for sustainability is a very pressing need. And I'm addressing at least those who are inclined towards chemistry, material processing, including biotechnology. So the question I ask, how should chemistry change in the 21st century? We need to reinvent chemistry practice and processes for a sustainable future. And chemistry must be used as sustainability science that connects molecular level events with planetary level consequences. You operate in the invisible world, but our doing manifests on a planetary scale. And I think every chemist must develop that consciousness, because this will trigger new thinking. That's very important. Okay. The role of chemistry is central in quest for sustainability, like the decarbonization of energy resources, defossilization, decarbonization. These are good words to use, but very few people who talk about it fully understand what is the kind of challenge involved here. And I can give you some examples how it can be done. It's very simply. Can we have an ambient ammonia synthesis? Why it is such a big guzzler? Because ammonia synthesis is done in temperature between 500 to 1000. And pressures of 200 to 1000 atmosphere. That's why energy guzzling. Why not ammonia synthesis at room temperature? Many advances have been made. We are not anywhere near there, but this is one of the hottest topics of research in chemistry. Look at the carbon dioxide concentration. This summer, in month of May, we achieved the highest carbon dioxide concentration in the atmosphere, 415 ppm, which has remained static for nearly 800,000 years. There's been a spike post-industrial revolution, but in last 50 years, dramatic hike in the carbon dioxide concentration. So the question is, what do you do with this carbon dioxide? One is don't emit. But chemists can help in retrieving the carbon dioxide, which is already in the environment. So you need sequestration, because it is there in very, very small concentration in ppm. First, how do you pluck? You need molecular sponges. Like a mop, when you remove you spill something on the floor. You mop it and then convert carbon dioxide, possibly into proteins. So this nuisance that we have carbon dioxide, this has been now demonstrated in the last couple of years that carbon dioxide can be converted into amino acids. And you know that amino acids are the building blocks of proteins. So if I can extrapolate, food can be produced from carbon dioxide in principle. So think about this. Artificial photosynthesis. All this production or carbon dioxide is consumed because trees carry out efficient photosynthesis. That's the heritage of evolution. Can't we not replicate photosynthesis in the laboratory? This will also enable production of green hydrogen, which is considered as a very essential and fuel for the future. And I mention this because it is relevant for our country. You know that I consider that addressing some of these problems is once in a century opportunity for chemists. Once in a century effort. Don't miss it. You are young. And you also know that India had announced last November that India will be carbon neutral by 2070. It's an unbelievable challenge. But the fact that country is in a resurgence mode, it can be handled. But you have to deep dive, find out what is it required to meet this huge, huge challenge. And actually, if we can achieve this target, we will be world leaders in every sense, Now, some of these challenges that I have mentioned are all rooted in basics of chemistry. But remember, chemistry alone can't provide complete solutions. Chemistry must adopt systems approaches in practice and embrace interdisciplinarity. You know, engineers like Professor Murthy and our chairman, Mohan Reddy, are very familiar because engineers work through systems and systems approach are very well established. Biotechnology and biology adopted 20, 30 years ago. But chemists have skirted systems approach. Last 5 years, as a part of an international group, we are propagating this idea. We have written extensively in the last 5 years in almost all the leading fora of the world that chemistry must adopt systems approach. I mean, you know, you make what you want to and forget it. That's why we have created a mess. That's not the approach, okay? So issues like what, why, and how we make chemical entities. You must understand why, what, and how we make. Their environmental footprint and life cycle management, which now can be, we have proposed again, which now can be defined as circularity index in each case, and adherence to the R3 principle must be evaluated in real time. This is the way forward for chemistry. We don't think, I'm sure many of you find this somewhat alien, but it is not, because that's where the future is going to be. Emphasis needs to shift from traditional atom economy concept to the dynamic idea of atom circulation. You know, you do atom economy, atoms can't disappear. So keep atoms in circulation, and then there will be no waste. In fact, I don't want to bother you because I've already taken too much time, but the concept of waste has to be jettisoned. Look at the common terminology that you use, throw away. Can anybody in this audience tell me where is this place called away? You always say throw away. Where is the away? Which is that location? So these are issues that chemists have to understand first and address, because common man may follow what we advise them, but they can't find solutions to this. Okay, in short, systems thinking approaches should be the pivotal guide in both discovery research and process innovation in academia and chemical industry. In this context, one is entitled to raise some provocative issues, and I'm notorious for raising provocative issues. I will only mention one of them, because if I raise too many, you will drive me out. Is it possible to, I ask a question to all the chemists and practitioners of chemistry. Is it possible to carry out chemistry without chemical reagent? I'm sure you say I'm nuts, maybe. But we have to do chemistry without chemical agents. If so, if we can, it will reduce the use of chemicals in affecting chemical transformations and dramatically reduce the hazards of wastage characteristic of workup procedures, particularly notorious for water consumption, waste generation, and environmental pollution. Indeed, use of heat, light, microwaves, ultrasound, and mechanical energy for affecting diverse reactions in solvent-less and workup-free processes will be the likely future. I'm just sensitizing you with some words, if you have not heard them before. Keep them circulating in your mind. Continuous flow chemistry and its coupled variants offer remarkable scale-up possibilities and is already getting traction for speed, compactness, and efficiency, and are being rapidly adopted by chemical industry globally. In India also, some few baby steps are being taken. The possibility of room or even a tabletop chemical plant is a real possibility. Just imagine, normally you identify chemical plants by the exhausts that you see. It is possible to have a tabletop chemical plant now, and you can manufacture in tons, this has not yet percolated, but this is the cutting edge technology and the thought processes which are on, and I just want to sensitize you. In short, chemistry should reincarnate as sustainable chemistry in 21st century for the benefit of people and the planet. Digital revolution is transforming chemistry through automation and extensive use of AI, ML, IoT, and data mining. I'll give you some examples. From synthetic planning to retrosynthesis, route selection for manufacturing, identification of new targets and lead molecules for drug discovery through in silico docking experiments, 3D printed designer vessels. When you want to do a chemical reaction, everybody orders a big reactor and all this. Why can't you make efficient designer vessels which will facilitate manufacturing of chemicals? You can even have catalyst embedded in 3D printed vessels. You don't have to add external catalyst. You have to ask these questions. In fact, it is now possible to have pre-packed capsules for specific transformations, and these are some of the possibilities being explored for full digitized manufacturing, and this transition is underway. Okay, so finally, thank you for inviting me to share some thoughts. There is little doubt that the double engine of sustainability focus and leveraging of digital tools will drive chemistry agenda in academia and industry in the coming decades with new innovations and reduced environmental footprint. Let me end by reminding that your new look premises and creative pursuits in partnership with other knowledge streams, which are plenty in your locations, like chemical engineering, which is absolutely necessary. I told you about Haber-Bosch process. Haber process, everybody remembers. Two people got Nobel Prize for ammonia, Haber and Bosch. Bosch was a chemical engineer. Haber said you can, under those drastic conditions, make ammonia, but it was Bosch who made it an industrial process. It's a very important story or a precedence to recall. Make sure, and you are in location, which I learned now, that you are well integrated, well connected, work in partnership with life sciences and material sciences. This is the way forward. So lastly, your promises to keep. And as Obama used to say, you can, we can. Thank you.
Thanks a lot, sir, for sensitizing us about our existence depends upon molecule. what, how, and why the systems can be adopted in chemistry for a sustainable future. And I hope everyone in this room will take a oath to do their bit to contribute to the challenge of being carbon neutral by 2070. Now I request our Director Sir, Professor B.S. Modi, to give one souvenir to the virgin guest.
Depends on the telescope resolution that you use. Much better. Sure. One moment. Oh, yes. And,
Now we came to the end of the today's ceremony, but not end of the journey we started today. Now I request our Dean Planning, Professor K.V. Subramanian, to propose the vote of thanks.
Good morning to one and all. It is my pleasant duty to propose the vote of thanks. First, the formalities. I'd like to thank Professor Govardhan Mehta for gracing the occasion, for sparing his valuable time, and for an inspiring lecture. Sir, I've heard you before, and I always look forward to your lectures as something that is thought-provoking. You certainly left a lot of thoughts in our young students who are here, and hopefully charted a direction forward for the chemistry department. I'd like to thank Dr. B.B.R. Mohan Reddy for gracing the occasion. Dr. Mohan Reddy, we are very fortunate to have him as our Chairman, Board of Governors. He's been very encouraging and has helped us move forward along our chartered vision. So we've managed to achieve the growth thanks in part to the encouragement that we get from Dr. Mohan Reddy. To my chemistry colleagues, students, I do have to mention that there's been a silent partner in the progress of construction. While I was involved in the construction of the building, it was our director, Professor B.S. Murthy, who has been constantly behind the scenes pushing and getting the building completed on time, has been in a great part due to the encouragement and the push that we got from Professor Murthy. This building that we inaugurated today has been a culmination of activity that started in 2010. And several of my colleagues who are here will attest to the fact there have been several ups and downs, several aspects of designs that have been changed. And finally, we ended up with a building that we inaugurated today. So I do have to acknowledge several actors who were involved along the way. I'd like to put on record thanks to the architects, Arcop and Associates, who worked with our faculty and students, took their input in designing the building, the architectural aspects of the building, the functional aspects, the whatever other requirements are done, those were painstakingly addressed in the design of the building. I do have to thank the construction group headed by L&T, which essentially was responsible for the construction, and Tata Consulting Engineers, who have been our partners in monitoring the construction and ensuring that the quality of the building is maintained and that we've managed to stick to time in completing the building. And of course, I'll be remiss in my duties if I did not mention the contribution of our CMD department, which has been actively involved in the planning and the execution of the project. So I'd like to conclude by congratulating the chemistry department on your new building. I do hope that you enjoy your new building. But I do want to acknowledge the contribution of the early pioneers of our chemistry department, Professor Khan, Professor Deepa, Subbu, Tarun. They were all here during the planning of the building. So while we were involved in the execution, a lot of the input came from our faculty and even the students who were involved in the planning effort of the building. So we managed to produce a building within the limited resources that we had, hopefully covering all the functional aspects. We've not missed any of the major functional aspects in the building. There will be some teething troubles as you occupy a building, but hopefully the buildings will live up to what they're meant to be. So thank you, and congratulations to the chemistry department once again.
Thanks a lot, sir, for briefing us about how the building has started. Now I request all of you to please raise for the National Anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Sir, we declare please. So with the permission of Honorable Director, sir, we declare the event closed. This is Mitali Wal, sign off. Thanks for joining us. Jai Hind.
Thank you.